And today's topic is the Bitcoin messaging and the BTC swap via zkBridge. So we are from the Polyhedra Network, and I'm the co-founder and chief scientist. So the first thing is about the introduction of the Polyhedra Network. So for people who don't know our team, we work on zkBridge and other related things in zk. So the first one is the zk interoperability, and the killer app is zkBridge. And in zkBridge, we design and implement the application with Virgo, and Virgo is a new zkP protocols invented by our co-founders. And we're providing the trustless and efficient infrastructure for asset and data interoperability in Web3. And zkBridge uses the zkSNARKs, being both the prover to efficiently convince the verifier chain that a chain certain state transaction happened on the center chain. And we will dive into the details later. This is the basic concept. And the second thing is the innovative algorithms. We have developed and deployed several next generation zkSNARK protocols such as Orion, Virgo, Gemini, Merlin, and Pianist. And we have open sourced the world's fastest zk proof system expander recently. You can take a look into our GitHub, and you can download the code and try by yourself. Okay, and these protocols can be used in a wide range of zkP infrastructures and applications. And last things, we also have the developer tools, and we work together with Google Cloud to build Proof Cloud, providing full stack zk proof with the most efficient zk algorithm I mentioned in previous session. And we also provide various services to over 18 ecosystem partners and their developers. We use these techniques to improve interoperability, efficiency, and security. Okay, this is a basic introduction for our company. And next, because the core technology is zk, so we also have the the blueprint and also the future map of the technology of zk. This is also a brief introduction for this part. We just divide all these things into three parts or three layers, as you can see here. And the bottom layer is protocols. That means we have new algorithms and basic fundamental protocols to support the zk technology. And in the middle layer, we have the foundation. So in these foundations, we have many things utilizing these fundamental protocols. And we can design distributed zkP protocols. We also design hardware-friendly zkP, and with these new algorithms, we can integrate it with the proof cloud, so every people can use our proof generation systems. And on the top left, there is application. Okay, we have multiple applications empowered by the technology of zkP, including the zk Oracle, zk aggregator, and also as well as zkBridge. Here I also want to highlight the AI plus zk. So it's a new area appearing in the past years, and they combines two new technologies of AI and zk together to provide the integrity, privacy, and even security for the AI models. So that's a blueprint for zk in our company. And this is the expander. It's our recent work. I want to highlight here. We have the fastest proving system, which we call expander, and we open source the code of the expander. And this is the specific gigabytes in expander. And if you are you have the technology background and you are engineering or coder, you can just download these systems and try to use it. And if you have any feedback, you can just have issues in our GitHub repo. And the last thing for the expander is the zk in the cloud. We collaborate with Google Cloud together to build the proof cloud system. That means you can use the technology ZK in Google Cloud. We can provide the bottom algorithms and proof generation system, and you just use the API and you can use this cloud and technology to generate proof for your applications and for your need. Okay. Okay, so everything is going well. Any questions here? Okay, and next we will dive into the details. I think today is a technical talk, so we have some technical details here. So this is zkBridge. This is our killer application, and it is also the fundamental approach for the future BTC swap protocol. So as you can see here, we want to build bridge between different chains, right? We want to do a communication between different chains in the blockchain universe. And this is very important because you need communication and interoperability between different chains. So here is a simple example. So in the bridge, you have two chains. The first thing is this is sender chain, and this is the receiver chain. So the sender chain want to send the message to the receiver chain. So they have the communication. And in here we just have the single example with the token transfer. So in the beginning, for the user on the sender chain, he can lock their tokens with some and this is a message or operation on the sender chain. And then we have the block header relay network. So here we have some nodes in the network, but it's permissionless. That means anyone can join the network and can be the proof generator. And all these generators in the network, they can generate the proof. What's the proof? The proof contains that confirmation of the operation of the sender on the sender chain. Right? So you need to get a confirmation on the sender chain. The operation has confirmed, has finished. And then this generator can send the proof to the receiver chain. And we deploy the smart contract on the receiver chain. So the smart contract can validate the proof automatically and update the corresponding operations on the receiver chain. So if the lock operation has been confirmed on the standard chain, the proof will be generated by the proof generator in the network, and the generator will submit the proof to the smart contract on the receiver chain, and the smart contract can validate the proof is correct, so the receiver chain knows the user has locked some tokens on the standard chain, so he can mint the same amount of tokens on the receiver chain. Then you finish token transfer. And here is trustless because it relies on the proof generator in the network. But even though these proof generators are malicious, they cannot fake the proof, because the security of zero-knowledge proof is guaranteed by mathematical formulas. You cannot fake proof even if you are malicious node. So this is how it works, how zkBridge works for the cross-chain bridge in the blockchain. Okay. And we also propose a general zkBridge. That means beyond the connecting different chains in the multi-chain universe, we can connect variance data and other things, the different systems between the Web 2 and Web 3, because all of this is data transfer between different layers, and you need to prove something from the source to the terminate. So you can use the same mechanism to build the connections between Web 2 and Web 3. And the last part, we will move to today's main topic, the zkBridge for Bitcoin. So similarly, we can use this technique to connect the Bitcoin network with all other blockchain ecosystems, including Ethereum, OP, Avalanche, and many different chains. Okay, and I will use two examples to explain how zkBridge can help to build the Bitcoin ecosystems and do transfers between Bitcoin network and other networks. So the first thing is Bitcoin ABS. It's the trust minimized bridge from the Ethereum to Bitcoin. So you can see it is unidirections from Ethereum to Bitcoin. And it is simple because although Bitcoin cannot support smart contract, the Ethereum can support smart contract. That means it can support various operations on Ethereum. So as you can see here, in the beginning, we have the staking validators on the Ethereum chain, and they just stake ETH on Ethereum chain. And then we have some bridge request from the Ethereum to Bitcoin, and it is from the user's request. So the staking validators can write some bridge data to the Bitcoin because it is a bridge operation. You need to pass the message or some information from Ethereum to Bitcoin, so you can write some data to Bitcoin. Then we use zkBridge to bridge the data blocks from the Bitcoin to the Ethereum because Ethereum supports smart contracts, so Ethereum can validate the proof about some information on Bitcoin. Okay. So if the data is correct, then the data or the message or any operation will be confirmed on Bitcoin network. And then the proof generator in the network can generate such a proof that such a proof about the Bitcoin chain to the Ethereum. And Ethereum has a smart contract, and smart contract can validate the message. If it's correct, anything is good, we pass a message from the Ethereum to Bitcoin. If there are any malicious nodes in the network and they didn't bridge the correct data to Bitcoin, then the Bitcoin chain block will be incorrect. And the message will also be passed to Ethereum chain. And we can slash the malicious validators. This is the mechanism. Very simple with zkBridge. Any question here? Okay, and lastly, I will talk about the second example, which is a fully trustless cross-chain Bitcoin token swap via Bitcoin. This is a mechanism. We still have the Ethereum and the Bitcoin. Here, the standard chain is Ethereum and the receiving chain is Bitcoin. We want to transfer the Bitcoin from the Ethereum to the Bitcoin network. And we have some users. And here we assume we have maker. And in the beginning, in order to ensure the maker is honest, we enforce the maker to make deposit to both pools on Bitcoin network and Ethereum. Okay. And then for the user, he can send the WBTC on Ethereum to the liquidity pool on Ethereum because he wants to do token transfer. He wants to transfer his token on the Bitcoin network. So this is the second step. And for the third step, the maker can transfer the Bitcoin to BTC to the user's receiving address. So the user deposits Bitcoin on Ethereum, and the maker transfers back BTC to user's address on Bitcoin. But it is unsafe. So how can we address this challenge? We use zkBridge. We use zkBridge to confirm this information. The maker has transferred the same amount of BTC to user's receiving address on Bitcoin. And when the smart contract on Ethereum receives this message or the confirmation via the zkBridge, it can do the finalization and release the token to the maker. So the maker gets some BTC from the Ethereum and transfers BTC to the Bitcoin network. And from the user's perspective, they finish the token transfer. Okay, any question here?
So what is the liquidity pool on Bitcoin?
if you want to use this application, you need to have such a pool at the beginning.
Yeah, just some address, right?
Yes, some address.
But
It's a liquidity.
But who control it?
No one can control it.
Okay.
Yeah, you don't need anyone to control this pool. Because the maker cannot do malicious operations, the maker needs to log assets on both pools. So if the maker doesn't transfer BTC to the receiving address, he will his token on Ethereum will be not won't be released. So that's the mechanism. And finally, this is our social our accounts on social media, GitHub, Discord, and Twitter. So that's all. Thanks.